Hello and welcome to Get Wise with Perrywise. I'm Matthew D. Perry of Perrywise IT Consulting, and today we'll be addressing IP addressing. What is an IP address? It's a unique identifier for a device on a network. It enables communication between networks and it involves source and destination in data packets. One key thing to remember is that every device on the network, no matter what it may be these days, whether it be a computer or a smart toilet, has an IP address. You have Internet Protocol version 4 and Internet Protocol version 6. IPv4, as it's more well known, has 4 blocks of 8 bits each in the IP address. Each address is in 32 bits, and there are 4.3 billion IPs in total. This is the more traditional IP address you might have seen with 192.168.1.1 or something of that nature. Meanwhile, IPv6 has 8 blocks of 16 bits each. Each of those addresses is 182 bits, with 346 trillion IPs in total. That's 1,028 times as many IPv4 addresses in existence, and why they have IPv4, so they can have more IP addresses. When it comes to IPv4 addressing, an IP address occurs such as 192.168.1.1. That's 4 octets in between the periods made up of an 8-bit number that corresponds to a respective binary indicator. Those octets range from 0 to 255. So, the above IP address would be that in binary. Another element to keep in mind are private and public IP addresses. Public addresses are used for WAN and Internet applications, given from the router from your Internet service provider. Private IPs are used within the local area network and not used for Internet routing. This would be for, let's say a printer or other such appliance. Addresses for those range from 192.168.0.0 to 255.255, 10.0.0.0.0.2, 255.255.255, and 172.16.0.0 to 172.31.255.255. Some of these unique addresses are registered by the regional Internet registries under the oversight of the Internet Assigned Numbers Authority, better known as the IANA. Finally, we also have static and dynamic IPs. Static IPs are IPs that are manually routed. You manually type in the number to get to them. And dynamic IPs are ones that are given through the Dynamic Host Control Protocol, and they keep changing. We also have classes of IP address. Class A is a large class. That's 10.0.0.0/8. We have 8 bits for networks, 24 bits for hosts, and over 16 million addresses overall for that network. Class B is medium. You have 172.16.0.0 to 172.31.255.255/16. That's 2 octets for networks, 2 for hosts, and over 65,000 usable addresses. Class C is small. This network is 192.168.0.0/24, and there are 254 usable addresses in that pool. Class D is solely for multicast addresses, and Class E is solely for experimental use. We also have the Direct Host Control Protocol, or DHCP for short. The DHCP pool is essentially a bunch of addresses your server will provide to devices. Your lease time is how long the server will store those IP addresses within the device. And also to keep in mind is DORA, the 4-step process to discover devices, better known as discover, offer, request, and acknowledgement. We also have some terminology I just wanted to cover very briefly. The subnet mask is the part of an IP address that defines which specific part of an IP address identifies the network and host. The default gateway is used to route a device that uses to send traffic to other networks. CIDR notation, aka classless interdomain routing, is a shortened way to represent a subnet mask using a slash, followed by the number of network bits. A network address identifies the whole network, and the last octet ends in 0. It's the first address in a subnet and cannot be assigned to a device. The broadcast address, meanwhile, is used to send data to all devices on the network at once. The last octet will end in 255. It is the last address in a subnet and cannot be assigned to a device as well. Some troubleshooting when it comes to IP addresses include duplicate IP addresses, DHCP failure, incorrect subnet masks, and wrong gateway are all common IP addressing problems. If you open up your CMD window and try ipconfig/iappconfig, you'll get some network information that you can use to fool around, troubleshoot further. You can also use ping on a respective IP address to verify if a connection can be made to an IP address. And you can either use tracesearch/traceroute to trace connections and see what is going wrong and where. Alright, today we messed around with IP addresses and we got wise to address classes and other definitions. There's more to come with IP addresses during the Network++ season, so stay tuned on more Get Wise with Perrywise.